All right, so we start. So I'm in the this one, chapter 8. So we started chapter 8 in last class. Uh, I talked about ionic bond, and covalent bond, and metallic bond, and uh, number of outermost electron in each element is equal to its group number, right? So if you look the element in group one, you have lithium, sodium, potassium. So they all have one electron like this. So if you look the group two element, so beryllium, magnesium, calcium, they have two electron like this. So if you go to the group five, group three electrons, so it's a boron, so it's a three. So we have 1, 2, 3 electron like this. And if you go to the group four element, which is a carbon, they have four electron outermost orbit like this, right? So this is very important. And if you go to the group six, so oxygen 2, 4, 6 electron like this. Go to the 7, you have 7 electron, 2, 4, 6, 7 electron. And if you go to the F group, like the sorry, this is a boron carbon. I think I missed the nitrogen here. Group 5, nitrogen, oxygen, and then the fluorine. This is fluorine, and then neon has 8 electrons. So what is its group number? That is the number of electrons in outermost orbit, right? So that I told you in the last class. So this is called the Lewis structure. Now let's go to the slide number 5 and try drawing some molecular structures here. So let's say I am making this CS4. This is carbon bonding with 4 hydrogen like this, right? So what is its structure? How do carbon and hydrogen sit together there? So carbon is in group number 4. Group number 4, and carbon has 4 electron in outermost orbit, right? 1, 2, 3, 4. So we are not concerned in the inner electron. We are just concerned in the outermost electron. So carbon. So I'm going to write carbon here, and I write 1, 2, 3, 4 electron like this. 1, 2, 3, 4 electron like this. Yeah. Now you can make a circle here, but circle is not necessary. Yeah. You can make a circle, but circle is really not necessary. We just want this 4 electron here. Make sense? Now, how many hydrogen we have here? 4 hydrogen. So I put 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, like this. So where is the hydrogen? Hydrogen is in the group 1. So if you look at the periodic table, hydrogen is in the group 1, so it has 1 electron, right? So hydrogen has this 1 electron here, 1 electron here, 1 electron here, 1 electron here. So that red electron is coming from the hydrogen, and those black electrons are from the carbon. So what they do is they share. So this and this share this electron. So hydrogen gives this electron to carbon, carbon gives this electron to hydrogen, and then they develop a bond here. And same here, like this, and like this, and like this. Now count the number of electrons. So this can be written like this. So this is carbon, hydrogen here, hydrogen here, hydrogen here, hydrogen here. So each of these 2 electrons represent a bond like this. Make sense? So like that. So count the electrons. So around carbon, how many electrons now? 1, 2, 3, 4, 5, 6, 7, 8. Carbon has 8 electrons. How many electrons hydrogen has now? This hydrogen has 1 electron. This also has 2 electrons. This hydrogen has 2 electrons. This hydrogen has 2 electrons. So all other elements try to have 8 electrons around them, and hydrogen try to have 2 electrons around them. And if that is the case, the structure we write is good. Make sense? Good, like that. So let's look another one. I have some example here. So let's look the water. So this is CS4, it's called methane. I just finished this one. Now let's look water. So Lewis structure of water. Water is H2O. So let's write the central atom. So this guy is the central atom, which is only one. That is called central atom. Yeah. So O is here. Where is oxygen? Oxygen is in group number 6. How many electrons are here? 1, 2, 3, 4, 5, 6. Right. So I'm going to write the 6 electron there. 1, 2, 3, 4, 5, 6. So like this, oxygen 6 electron. Now I'm going to write the hydrogen here. So this is hydrogen. This is maybe I write the hydrogen here. So how many electron hydrogen here? Hydrogen is in the group 1. Hydrogen is in group 1, so it has 1 electron. So I write the 1 electron here. I write the 1 electron here like this. Yeah. So this. No question here. So this hydrogen gives this electron to oxygen, and this oxygen gives this electron to hydrogen like this. So they share these 2 electrons. So one gives another. So they keep exchanging their 1 electron. And the same here. So this goes in its field and it goes to its field. So they share this electron. So water looks like this. So if you see here, so what is this? So oxygen. So maybe I write with the black and the hydrogen here, and then another hydrogen here, and you have 2 electrons remaining down here, 2 electrons remaining up here. So this is the structure of the water. Easy? We just keep track of the electron. Now let's look the ammonia. In the note, I might have put the 2 electron here and 2 electron here. So in the note, you might see like this. It's the same thing. It's the same thing, yeah. Either you put here or here is the same thing. And these 2 electrons. So this bond is 2 electron here. So this is called a bond pair. So this is called BOND, bond, PAIR pair. So in this bond there are 2 electrons. That is bond pair. And in this bond there are 2 electrons. So this is also bond pair. So they are not bonding. So they are just sitting there. They are called lone pair. LONE, lone pair. So this is very important concept. Bond pair and lone pair is very important concept. Yeah? Make sense? Good. So again, if you look here, this is a bond pair, because they are forming bond. This is also bond pair, and this one and this one is called lone pair. So lone pair. This is lone pair. This is lone pair. So if there are electrons and they are not bonding, they are called lone pair. Now let's look one more. So if you count the number of electrons around the oxygen here, 1, 2, 3, 4, 5, 6, 7, 8, right? Around oxygen, you have 8 electrons here. Around hydrogen, 1, 2 electrons. So around hydrogen, you try to make 2 electrons. Around oxygen or other the central atom, you try to make the 8 electrons. Yeah? Good. Now let's look at one more. So ammonia, I have ammonia here. So ammonia is this one, NH3. So right, this is the only one. So that is called central atom. So this is in the lab number 13. So I put a folder in this chapter. So you go through the lab number 13 and you'll see a lot of structure there. So this is nitrogen. Nitrogen is in group 5 here. So 2, 3, 4, 5. So 5 electrons with nitrogen. So 1, 2, 3, 4, 5. You put like this. And then you put the hydrogen. So I put hydrogen here, another hydrogen here, another hydrogen here. I have 3 hydrogen like this, 1, 2, 3, right? Now, so 1, 2, 3, 4, 5. These electrons are from nitrogen. Now this electron is from hydrogen like this. This electron is from hydrogen. Now hydrogen and nitrogen share these 2 electrons together. These 2 electrons together. These 2 electrons together. Now it looks like this. Maybe that's fine. So what happened here is, now let's draw the structure of this one. So nitrogen is here, hydrogen I have here, another hydrogen I have here, another hydrogen I have here. Now I have how many electrons left here? 1 and 2, right? So we put these 2 electrons together and that is called the lone pair. So in this one there is 1 lone pair. This is LONE lone pair. This is lone pair. Right here, these are bond pair. BOND bond pair. Bond pair. This is bond pair. Bond pair. This is also bond pair. Bond pair. Now count the number of electrons around nitrogen. Here 2, or you can do here 2. 1, 2, 3, 4, 5, 6, and 7, 8. So including those lone pair, there are 8 electrons around the central atom, right? And around the hydrogen, this bond means 2 electron, this bond means 2 electron, this bond means 2 electrons. So around hydrogen there are 2, around other element, that central element, we put 8. If you draw something like this, you did good. All right, so now which of the following is the correct Lewis structure? So let's go to the slide number 6 and answer one question. Slide number 6. Oh, sorry, I mistake. Carbon here 1, 2, 3, 4. Nitrogen here 1, 2, 3, 4, 5. Oxygen here 1, 2, 3, 4, 5, 6. And then fluorine here, group 7. This is group 7. Fluorine here. Fluorine here 1, 2, 3, 4, 5, 6, 7. Like that, yeah. Now practice. Which of the following is correct Lewis structure? Let's look at the nitrogen here. Nitrogen, hydrogen, hydrogen. Now you don't have to draw to identify which one is right or which is wrong. You just count the number of electrons around it. So around this hydrogen there are 2 electrons. This is good. Around this hydrogen there are 2 electrons. This is good. Around this hydrogen there are 2 electrons. One pair. This is good. Now count the number of electrons around nitrogen. There are 2, 4, 6. There are only 6 electrons around nitrogen, but we need to have 8. So this is clearly wrong. Make sense? Good. So let's look another one. Now pH3. pH. So what is this one? pH, H, H. Now here are 2 electrons. So in the P. So look there. So with hydrogen 2 electron, with hydrogen 2 electron, with hydrogen 2 electron, with phosphorus 2, 4, 6, 8 electron. This is good. Central atom has 8 electron. Hydrogen has 2 electrons. Make sense? It's easy. Now you don't have to draw your own structure to identify which one is right and which one is wrong. Now let's look another one. Water. HOH. Here is HOH here. Now like this. So for hydrogen, good. Here. For hydrogen, there are 2 electrons. This is good. For oxygen, 1, 2, 3, 4. Only 4 electrons for oxygen. But oxygen must have 8 electrons outside, so this is not good. Make sense? So if they put like this, it will be good. Because 2 here, 4, 5, 6, 7, 8. But they didn't put these 2 electrons, so this is bad. Yeah? Good. All right, so now let's look another one. HF. Now HF. And then they give 2 here, 2 here. Now let's count. Around hydrogen, there are 2 electrons. This bond means 2 electrons, right? So this hydrogen has 2 electrons. This is good. Around this fluorine, 1, 2, 3, 4, 5, 6. Only 6 electrons. 6 electrons is not good. They must have to have 8 electrons. Yeah. So if they have put another pair here, it will be good. But they didn't put this there. Therefore, this is wrong. Make sense? Easy. Just count the electron around each atom. One bond is 2 electrons, and already they give those things. Now let's go to the slide number 7. I'm in the slide number 7. So let's look one here. CO is like this, and H like this, and then they have like this here. Now count the number of electrons around all atoms. So hydrogen has 2 electrons here. This is good. This bond means 2. This hydrogen has 2. This is good. Now count the electron around carbon. For carbon, so 1. This is 1, 2. This is 1, 2. 4, 5, 6, 7, 8. This is good. Carbon has 8 electrons. Make sense? So this is 2 electrons. This bond is 2 electrons here. This bond is 2 electrons. So 4, 5, 6, 7, 8. So 8 electrons. Around carbon, there are 8 electrons. Carbon is good. How about oxygen? Let's count here. 1, 2, 3, 4, 5, 6, 7, 8. So this is good. Make sense? So I'm just counting the electron around all atoms, and I'm looking whether hydrogen, near hydrogen there are 2 electrons, and in other atom whether there is 8 electron or not, right? If there are 8 electrons around other atom, this is good. If there are 2 electrons around hydrogen, this is good. So this is good. Now let's look another one. H, N, Cl, and H here, and they give 2 electrons here, 2, 4, 6 here like this. Now let's count the electron. Hydrogen, this is 2 bond mean 2 electron. This is good. There are 2 electrons. This is good. Now for chlorine, let's count 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is chlorine is good. Now let's look for the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. It's good. This is good. Yeah? Make sense? Good, like that. And then let's look another one. NO, O, then we have O here and H here. Let's count the number of how many they put here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Here 1, 2, 3, 4, like this. Now let's count the electron. For hydrogen, there are 2 electrons. This is hydrogen is good. Let's look this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is good. Now let's count electron around this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. This is good. Now let's count the electron around this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 1 1 means this is good. Now let's look the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen is also good. So this is good. Make sense? Easy, right? Now, how about the last one? Let's look the last one. Nitrogen here, 2, 1, 2, 3. 3 bond there, and I have nitrogen here. Oxygen here, 1, 2, 3, 4, 5, 6. Now let's count the electron around it. So let's count the oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is bad. Around oxygen, that cannot have 10 electrons. I can make only up to 8. Yeah? Like that. So this is bad because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's not good. So you can practice like this, yeah? So there are a lot of problems in lab number 13. So you can go there and just practice yourself, yeah? And then I put the compound there and count the electron. Now I'm going to do one from the slide number 8, and other thing you can do yourself. Now in slide number 8, I'm going to do one. So in why it is not good. So let's say 2 like this, and then they have minus. So other thing all makes sense. You just count the electron and that's you're good. Now let's count here the number of electrons. Here 2, 4, 5, 6, 7, 8. Oxygen is good. Now look nitrogen. Here 2, 4, 6, 2, 4, 6, 8. Looks good, right? Looks good, but this is not good. So why it is not good is like this. So if you look at the nitrogen, outside of nitrogen, how many electrons? 1, 2, 3, 4, 5 electrons. 5 electrons. And then if you look the outside of oxygen, how many electrons? 1, 2, 3, 4, 5, 6 electrons. So you need to have 11 electron species. But how many electrons we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is not good. So there are 2 things. So outermost electron number should be balanced, and around it there should be 8. There are 2 rules, yeah? So either first of all, you look whether there is 8 or not. Yeah, exactly, there is 8 around it. 1, 2, 4, 6, 8, good. 2, 4, 6, 8, this is good. But what is not good is that nitrogen, if you look here, there are 5 electrons. If you look the oxygen here, 2, 4, 6 electrons, 11 electrons. But here, if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So we should be putting 11 electrons there, but they put only 10 electrons. So this is not good. So this is a little bit tricky. Make sense? So I wrote there already, so you can read yourself, yeah? Now, let's look one. So other thing makes already sense. So why the last, the slide number 9. Now I'm going to do this slide number 19. So all other thing makes sense. You just count the electron and there are 8 electrons in each, so all are good. So now let's look this one. So this one. So this is also good. So H. So is it good? Around this hydrogen there are 2. Very good. Around this hydrogen there are 2. This bond mean 2. This is good. Around this hydrogen 2. Good. Around this hydrogen this is good. Now let's look the carbon. Around this carbon, this 2, this 4, this 6, 8. So this is good. So around this carbon, 2, 4, 6, 8. This is good. Yeah. So carbon is making double bond. This is good. So now let's look the last one. So sulfur, oxygen, oxygen like this. So they put like this: 2, 4, 6, 2, 4, 6, 2, 4, 6. Now starting on the electron. So 2, 4, 6, and these 2 makes 8. So this is good. 2, 4, 6, 8. This is good. Now 2, 4, 6, this 2, 8. Good. So for sulfur, these are 2, these are 2, 4, these are 2, 6. There must be 8 electron around sulfur. So there is no 8 electron, right? Not enough. So this is that. So only there around sulfur, there are only 6 electrons. This is not good. There must be 8 electrons. If they have done something like this, it will be very good. So if they have done like this, 2, 4, 6, 8, this is good. 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 If they have put the double bond here, that would be good. But since they didn't put the double bond there, put all of electrons toward that side, so this is not good because sulfur doesn't have 8 electrons. Sulfur only has 2, 4, 6. So it's a kind of the bookkeeping of the electron, yeah? Now, let's go to the, so pretty much all other things are there. So you can read yourself the slide number 1 of the lecture 2. So there are carbon dioxide. So they have like this. Is it good or not good? So let's look here. So 2, 4, and then in carbon like this. Is it good structure or not good structure? This is carbon dioxide. So 2, 4, 6, 8. This is good. 2, 4, 6, 8. This is good. 2, 4, 6, 8 around carbon. This is good. Yeah. So you just look yourself, and it's pretty much you can do yourself. Good. So let's go to the slide number 2, the formal charge. So now I'm going to the slide number 2 of the lecture 2, formal charge. CHARG formal charge, that's called FC. So this chapter is pretty easy, it's not that hard. So formal charge, let's calculate the formal charge. How we calculate the formal charge is like this. So let's say we have a compound like this, CH4. So what is the formal charge of carbon and formal charge of hydrogen? So we calculate like this. So formal charge FC is equals to which group is in carbon? Carbon is in group 4, right? So how many electrons they have? 1, 2, 3, 4. So this is, you write the 4. Valence electron, number of valence electron in the central atom. Make sense? So 4, and then minus lone pair of electron. Do you see any electron dot here? There are no electron dot here, so there are no lone pair. If there are a free dots there, they are a lone pair. They don't form bond. So that's 0 lone pair. No dots here. No dots. 0 lone pair, and then plus half of bond pair. How many bond pair here? 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 electrons there. Bond. So these are the electrons in these bonds, 2, 4, 6, 8, and then lone pair. This is lone pair. There is no lone pair, no dot, free dot here. And then the 4 is the how many electron carbon has in valence shell? 1, 2, 3, 4 outermost cell. So like this. Now calculate this one, and 4 minus 2, 4. This is 4 minus 4 equals to 0. So thermal charge in carbon is 0 in this compound. So this carbon doesn't have any charge. Make sense? No plus, no minus. Now look the thermal charge in hydrogen. Thermal charge in hydrogen. Thermal charge in hydrogen. Thermal charge in hydrogen is how many, which group hydrogen is in? Hydrogen is in group 1. Group 1. Hydrogen is in group 1. 1 electron. So put that 1 here and minus how many valence? How many dot here? No dots here. So it's 0. No lone pair around hydrogen, right? So that's 0. And then plus, and how many bond pair here? I'm just looking one hydrogen. I'm not looking all hydrogen here, yeah? I'm just looking one hydrogen. Let's talk about one hydrogen. So plus on the half, and then one hydrogen has 2 electron here in bond pair, 2 here. So 2 cancel. So 1 minus, because 0 is not count, this becomes minus, 1 minus 1 is 0. So hydrogen has 0 charge, carbon also has a 0 charge in this one. Make sense? Now let's practice couple of things here. The slide number 3. Slide number 3. Let's calculate the thermal charge for water. So let's say water is like this. This is the water structure, and oxygen has like this. This is the Lewis structure. Now, what is the thermal charge in oxygen, and what is the thermal charge in hydrogen? Now we need to calculate. Let's calculate the thermal charge in oxygen. Thermal charge in oxygen. Thermal charge in O atom. So thermal charge in oxygen is now. First of all, you need to look the group number. Oxygen is in 6, so 2, 4, 6 electron. So 6 electron, right? So valence electron is 6 minus. Now put the bracket here and then count the lone pair. How many lone pair? 1, 2, 3, 4, right? There are 4 dots free. They are not. They are free, so they didn't form the bond. 4, and then plus and the half, and you multiply by. How many bond pair here? So this is one bond, this is another bond. So 2 here, 2 here. So 4. So that's 4. Now this becomes 6 minus. So this is 4 plus 2 to the 4. 2 multiply 1 is 2. Then 6 multiply minus 6 becomes 0. Yeah. So in water, oxygen doesn't have charge either. Make sense? Simple, right? Any question here? So let's look the one in the slide number 4. Slide number 4. Slide number 4 is, we have this compound here, C triple bond O, and then O has 2 electrons and C has 2 electrons. The thermal charge here in carbon. Let's calculate the thermal charge in carbon. Thermal charge in this carbon. So I'm just working for a carbon first. Let's do the carbon thermal charge. First of all, carbon is in group 4, so we have 1, 2, 3, 4 electrons. So I put 4 minus, and then now for carbon, I'm not looking oxygen. I just look the carbon. How many lone pair? 2, right? 2. So here are 2 lone pair, and then plus, and then half. How many bond pair around carbon? 1, 2, 3, 4, 5, 6. That's 6. So this becomes 4 minus 2 plus, this is 3. So that becomes 4 minus 5. That's equals to minus 1. So thermal charge in carbon is minus 1. Make sense? So just when we look the carbon. So thermal charge in this carbon is in group 4. So 1, 2, 3, 4 electrons. So I put 4 there. Minus, and how many lone pair? So these 2 are with the carbon and they are not in bond. So 2 plus 1 by 2, and then how many bond pair? 1, 2, 3, 4, 5, 6, 6, and then solve it in that. Now let's calculate the thermal charge for oxygen. Oxygen thermal charge would be, first of all, let's look the oxygen. Oxygen is 6, right? Around oxygen, there are 6 electrons in valence shell, minus now lone pair. How many lone pair in oxygen here? 2, right? 1, 2. And then how many bond pair? Plus half, and then 1, 2, 3, 4, 5, 6. 6. So that gives you 6 minus 2 plus, this is 3, then that becomes 6 minus 5, that becomes plus 1. So in oxygen, there is a plus 1 charge. In carbon, there is a minus 1 charge. Make sense? We calculate like this, and down there is some notes you can read yourself. So it's not really important. So the most important thing is you need to know how to calculate the thermal charge. Now let's look to another one here. Determine the thermal charge of the fermate ion. So I'm in the slide number 5. And in the slide number 5, in slide number 5, we have this compound 1, 2, 3, 4, and the double bond here, and then C, single bond here, hydrogen, and we have like this, and we have oxygen 2, 4, 6. We have a compound like this. So there is a bracket. You don't really need to know this one. So minus there. So we need to calculate the formal charge. Between the formal charge is the Fermat ion. So let's calculate the first in oxygen, right? Let's calculate in carbon actually. So let's carbon. So formal charge would be the carbon. Carbon is, I'm calculating for carbon. So carbon is group number 4 to 4 electrons. So formal charge would be 4 minus, and then I have how many lone pair with the carbon? There is no lone pair. There is no dot around carbon, right? So that's 0, and then plus and half, and multiply by bond pair. How many bond pair here? So 1, 2, 3, 4, 5, 6. 6 here, like this. Now that would be 4. So this is 3 here. So 4 minus, so 0 is gone. So this is 3. 4 minus 3 is 1. So carbon has plus 1 formal charge, right? Make sense? It's pretty easy. Now, let's calculate the formal charge of this oxygen here. So this oxygen here. So for this oxygen here, so I'm calculating the formal charge of this oxygen. Oxygen is it? 6 here. 1, 2, 3, 4, 5, 6. 6 minus, and then how many lone pair? 1, 2, 3, 4. 4 lone pair there. And then how many bond pair there? 1, 2. 1, 2, 3, 4. Plus half 4. So 6 minus, so 6 minus, so this like this. So 4 and 2 becomes 6. 6 minus 6 is 0. So that has 0. Make sense? Very easy. So now let's calculate the formal charge of the last one. Formal charge of this oxygen. So let's calculate the formal charge of this oxygen here. So again, the oxygen is 6, 2, 4, 6 there, minus, and then lone pair 1, 2, 3, 4, 5, 6 there, then bond pair plus half, and then bond pair is this 1, 2, 2. Then 2, 2 cancel. So 6 minus 6, 1, so 7. So that is minus 1 for that oxygen. Make sense? So here for this one, I think I got 0, right? For this one, I got 0. For this one, I got minus 1. For this carbon, I got how much? For 0. So this is 0. That was 0, and the formal charge here was minus 1. Make sense? So if you want to do hydrogen, you can do easily. So hydrogen is number 1. So if you want to do this for this hydrogen, so this is number 1. So 1 minus, there is no lone pair, there is no dot around hydrogen. 0 plus half, there is 2 bond pair here. This is 1 bond means 2 bond pair. 2, 2, 2 cancel. So that's 1. 1 minus 1 is 0. 0 plus 1 is 1. 1 minus 1 is 0. So this hydrogen has 0. Easy, right? So you need to practice a little bit in. Yeah, practice this one yourself in maybe sulfur trioxide. There is a time I have. So let's do one in slide number 6. Slide number 6, I have like this: sulfur, oxygen here, oxygen here, oxygen here. 1, 2, 3, 4, 5, 6, 2, 4, 5, 6, 2, 4 is like this. So it is asking me formal charge in S atom. So they ask us to calculate here. So formal charge would be sulfur. So sulfur is just below oxygen here. 2, 4, 6. So oxygen is in group 6. So you look at the periodic table. So 6 electron in outermost orbit, and then minus. Then how many lone pair? How many dot around sulfur? There is no dot around sulfur, so that is 0. And then minus, sorry, plus and half. How many bond around sulfur? This bond is 2, this one is 2, 4, 6, 8. So there are 8 in the bond pair. So this becomes 6 minus, so 0 is gone. So this is 4. This is 4. So 4, 6 minus 4 is 2. So plus 2. So this 6 minus 4 is plus 2. So sulfur has plus 2. Make sense? So you can, I already did those other for oxygen there, so you can look there. So I just did for sulfur. So there is another one in slide number 7. Exactly same, slide number 7, exactly same, but they put 2 dots here in slide number 7. So calculate the thermal charge in the sulfur. So sulfur is 6 minus, then lone pair is 2 here, 1, 2 here. Now you see that previously there was no 2 here, now there are 2 lone pair, and plus half, how many bond pair here? 2, 4, 6, 8. So 8, so it's like this. So this is 4. So 6 minus 2 and 4 becomes 6. 6 minus 6 becomes 0. Yeah? Easy, right? It's not that hard. So you just count electron. And now let's talk about the resonance structure. I'm in the next lecture slide, if you have pulled already. So I talk about the resonance structure. So we finished the 2 lectures in Canvas. Now I'm in the third slide, third lecture slide. Yeah. So this is not that many reasoning as chapter 7, so it's pretty fast. So group 3, 4, 5, 6. Yeah. Good. Now let's write the resonance structure. Resonance, R-E-S-O-N-A-N-C-E, resonance structure. Resonance structure. So what is resonance? So electron, everything is same. Electron change the position. Yeah. So electrons are just moving. Sometimes they come and sit this way in this chair, and after a moment they go and sit in this chair. So electron just change the position and sit in different seat within certain interval of time. Yeah. So this structure are called resonance structure. So this here. So this is oxygen, and this is oxygen. This is also oxygen. Now I'm in the slide number 2 of this lecture 3. Now you look here. So oxygen here, 2 electron here. Now 2, 4, 6 here, and then you look here is like this, right? So this is one structure. But what happens is that these 2 electrons, so this bond pair doesn't always sit here. They don't just sit here. So what they do is these 2 bonds, either these 2 electrons or these 2 electrons, jump this way, another side. So they just change their seat. So it is like this. So it was like that at the beginning. Now it is like this. 2 here. Now here there is 2, 4 like this, and this 2 electron is already gone this way. So this is oxygen here, 2, 4, 6, and previously these 2 electrons were here. Now these electrons jump to the another seat. So there is in the right chair previously. Now they go to sit with the left chair, like this. So these structures are called resonance structure. So 2 structures are exactly same. They are identical. But what is difference between these 2? The difference is that the electron just change the position from one to another, and this one is exactly same molecule. So this kind of structure are called resonance structure, and resonance structure is one of the most important concept in chemistry. Yeah. So those half filled orbital are very stable, fully filled orbital are very stable. I told a lot of those things in chapter 7. So they all come from here. So they just change the position of the seat. The electron change the seat position. So identical. So it looks like the double bond, right? And this look like the single bond. This look like the double bond, and this look like the single bond. But scientists measured this bond length, and they found that there are no double bond and there are no single bond. This looks like the single bond. This looks like the double bond. This looks like the double bond. This looks like a single bond. But they measured in the laboratory, and they found that there is no single bond, there is no double bond, and that is somewhere in between, like this. So oxygen here. So like this, like this, like this. So 1.5 bond. So they write like this. So when they write dot 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 like this, this is half bond, 1.5 bond here, 1.5 bond here. So this is 1.5 bond. This is also 1.5 volt. 1.5 volt. Make sense? So this is called the resonance structure. In the resonance structure, there is no single bond, there is no double bond. There is a bond somewhere in between single and double. Good. So if you see something like this is the single bond. This is single bond. Yeah, one bond. If you look like this, if you see like this is a double bond. There are two bonds. But if you see something one bond and dot like this, that's a 1.5 bond. 1.5 bond. So this is a 1.5. This is two bond. This looks like one bond. But in reality, this doesn't have a two bond in one bond. This doesn't have two bond in one bond. So if you look the molecule, this molecule has 1.5 bond. That's called the resonance structure. And if you look the bond length, normally double bond has short. This will be short. This will be long. But if you look measure the bond length here and here is same. So the bond length is somewhere in between 1.5, 1.5. Good. So I wrote that note in. It is the bond due to resonance is not single bond, it is not double bond, it is between single bond and double bond, somewhere 1.5. Yeah. Good. Now, let's go to slide number 3. So slide number 3 here. What are they saying here is which of the following is not correct Lewis structure? Actually, I already teased this concept previously. This is just for the practice. You can just count the electron around each atom and you are good. So now I'm going to do the wrong one. Why it is wrong? So this is nitrogen. I'm in the slide number 3. Yeah. So I just put this in for the practice. So nitrogen here and then oxygen here, like this. So why it is not right? So why it is not the right Lewis structure? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So around this nitrogen there are 10 electrons. This is clearly wrong. Nitrogen cannot have 10 electrons in outermost surface. Make sense? Easy, right? So I just look the nitrogen here. 2, 4, 6. 2, 4, 6, 8, 10 electrons around this nitrogen. There are 10 electrons. It's saying that 10 electrons, which is good. So, but here if you look 2, 4, 6, 8, this is good. 2, 4, 6, 8, this is good. But around nitrogen there are 10, so 10 cannot be possible. So let's look the another one. So YHC. So in the next slide, in the slide number 4. Slide number 4. So why it is wrong? So I already write the answer here. So you already know this probably. So 1, 2, 3, 4, and then here oxygen 1, 2, 3, 4. So why it is wrong? So you look here around carbon 2, 4, 6, 8, 10. Around carbon there are 10 electrons here. So this is clearly wrong. Yeah? Easy, right? So that cannot have 10 electrons. So other is good. All other has, if you count each of the atom electron around each of the atom, there are 8. Good. Now, so we are really moving fast. So this chapter, although it looks long, there are not many concepts. There are a couple of more concepts, and then we will be done. So some molecules don't follow octet rule. So go to the slide number 5. So look here. So here is a silicon. So silicon is bonding with fluorine, and then another fluorine here, fluorine, and like this fluorine. You see here, silicon is bonding with how many atoms here? 1, 2, 3, 4, 5. So like this, and then if you count the electron around silicon, 2, 4, 6, 8, 10. So this is this doesn't behave as an octet rule. So silicon don't follow the rule that we previously talked. Previously, I was talking around each atom, count the electron. If there are 8 electrons, you are good. But here, although there are 10 electrons, so around silicon, 2, 4, 6, 8, 10, this is good. Because silicon doesn't follow the octet rule. Yeah? Now, go to the phosphorus. So especially if you go to this, all these electrons, so this was group 3, this is boron. So boron, carbon, nitrogen, oxygen, fluorine, they follow the octet rule, 8 electron rule. But this sulfur doesn't follow that. This phosphorus can have more than 8 electrons. And then below carbon there is silicon. Silicon can have more than 8 electrons. This can have more than 8 electrons. This can have more than 8 electrons. Maybe chlorine, maybe this also can have more electrons. So the group 2, period 2 elements, these elements behave different way than this is the first period element. Yeah. So the silicon. Now let's look the PF5. So PF5. So this is P, fluorine, 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 and there is another fluorine also. 2, 4, 6, 8, 10. So phosphorus also doesn't follow the octet rule. So it has more than, it can have more than 8 electrons. Yeah, because this is in the another period here. So yeah, you can look yourself actually. So let's go to the SF6. So again, you look here, sulfur is in the another group, another period here, right? And then that also follows, don't follow the octet. So it can have more than SF4. So let's look the SF4. So SF4. So F here, F here, F here, SF3, SF4 here. Now, how many electrons sulfur has outermost orbit? 2, 4, 6. So one go here, one go here, one go here, one go here, 1, 2, 3, 4 is gone. Maybe 2 electron is sitting there like that. Yeah. So in the next class, how these structure look like, I will teach that concept. You got it, right? Sulfur has 6 electrons like this, 2, 4, 6, and then one is shared here, one is shared here 2, one is shared here 3, one is shared here 4. Now still sulfur has 2 electrons, and I just put that as a lone pair. Yeah, good. So if you count the number of electrons around sulfur, 2, 4, 6, 8, 10. It is not 8, but it's still good. But if it were with the carbon, nitrogen, oxygen, fluorine, if you see 10 here, not good. Yeah. Now, yeah, you can just look those yourself and how you feel. Yeah. Now let's go to the slide number 6. So just look those and try drawing. And so I'm going to teach one important concept here. This is very important. VSEPR, Vesper theory. Valence cells electron pair repulsion theory. Yeah, valence cell repel each other. So that means that. So if you look here, so nitrogen is like this. Sorry, let's look the ammonia. So ammonia look like this. Ammonia look like this, right? NH3, and it has one extra pair of electron. I already showed you how to draw those. Now, what happens is that valence cell means these 2 electrons here, these 2 electrons, these 2 electrons, and these 2 electrons. They all are called valence cell. Those which are shown in the bond or the lone pair, they are called valence electron, right? So valence cell electron. So this VS means valence cell electrons. This is valence cell electron. These are also valence cell electron. These are also valence cell electron. These are also valence cell electron. Now, valence cell electron pair. And then pair, and this is a repulsion. R means repulsion. Valence cell electron pair repulsion. So repulsion. So electron repel each other. Make sense? So those valence cell electrons are repelling each other. So this repel this one, this repel this one, this repel this one, this repel this one, this repel this one. So all are repelling each other. Those bond. Make sense? Bond and lone pair are repelling each other. Now the force of repulsion is like this. So lone pair, bond pair, lone pair repel the maximum, and then lone pair, bond pair repels a little smaller, and then bond pair and bond pair repel the least. Okay. So if you look here, if there are 2 electrons here and 2 electrons here, this and this repel with a very high force. Yeah, they really repel too much. But here we have only one, so we don't look here. So lone pair, I don't have only one lone pair here. So There is no lone pair repulsion. There is only one lone pair, right? Now look here, lone pair and bond pair. So this repels this one with great force. This repels with this one with great force, and this also repels this with a great force. Lone pair and bond pair repel with very high force. Yeah, a little bit less than lone pair. Now, which repel each other very least? This one. So this is a bond pair. This is a bond pair. This is a bond pair. So this and this repel each other, but with a very small force. This and this repel with each other with a very small force. This and this repel each other with a very small force. So this is called VSEPR theory. So if there are 4 free electrons there, they repel the most. If there are already everyone, so I'm going to stop it. Yeah. So we will continue from here. So there are a couple of things in chapter 8 now. So chapter 8 is pretty much easy. Thank you everyone. So I'm going to stop this one.